Hello there. We are very happy to have you all here. To begin this seminar, I'd like to introduce you to the Deputy Director of the UCAR Scientific Partnerships and Services Center, as well as CPAESS, Cindy Briere.
Thank you very much, Alex. Welcome, everyone. We are absolutely delighted to have you attend our CPAESS Discovery Seminar series today. Our CPAESS scientists do everything from exploring our ocean depths and flying into hurricanes to heliophysics modeling and unraveling the mysteries of the Arctic. As CPAESS, we are very proud of our scientists and delight in sharing their work with the public, the NCAR UCAR community, and our many colleagues across universities across the globe. To orientate you, we are going to use Slido today for questions, and it's right below the presentation on your screen. You are welcome to post questions anytime during the talk, and we will address the questions after the presentation. And now it is my sincere pleasure to introduce today's speaker, Dr. Zinkann. Anne has been working on a variety of topics across the international sphere. To name a few, the UN Decadal, Global Ocean Observing Systems and Data, and also participated in various research cruises in the Arctic and across the Atlantic Ocean. Anne is a CPAESS project scientist at NOAA's Global Ocean Monitoring and Observing Office, GOMO for short. Her responsibilities including working with WMO, Atlantos, Ocean Ops, UN Decade, and the GOMO data strategy. So please join me in welcoming Dr. Zinkann today, who will be speaking on what other than international cooperation, why, who, and what. Over to you.
Thank you so much, Cindy. And I'll get right into it and get started. And I thought it would be helpful to briefly talk about my career path and how I got to where I'm at today, which is, I started out somewhere completely different than I am today. So in my undergrad, I worked on deep sea shark biology, wanting to be the dolphin wrangler and work with sharks like every other child and teenager, but quickly discovered that everyone wants to do that. So I tried to find a different niche. So I started working in Antarctic deep sea ecology, using biogeochemistry, stable isotopes, and fatty acid analysis, and was in Germany back then. I'm originally from Germany and grew up there. And then did my PhD in Fairbanks, Alaska, which is the first time I moved on to saw the US to work on Arctic ecology on the Chukchi Sea shelf up in Alaska. And then quickly realized I had this path kind of laid out that I thought I was gonna follow, which was academia, but quickly within like first 2 years of my PhD realized that that's not quite where my passion lies, and then try to branch out and figure out what other opportunities are out there. And that's when I found the KNAUSS Fellowship. The KNAUSS Fellowship is a marine policy fellowship hosted by Sea Grant, National Sea Grant, and you can apply and then are hired to do 1 year of program management and learn how the policy sphere works in the executive and legislative branch. So I was with this great cohort the year of the COVID shutdown and moved to DC and was placed in a NOAA line office in GOMO, as Cindy already said. And just quickly to go over this, I'm not sure how familiar everyone is with NOAA, but NOAA has 6 line offices. I'm sitting in the Oceanic and Atmospheric Research, OAR for short, line office. And under that, we have multiple programs and laboratories. And I sit in this little tiny orange bubble there under David Legler, the Global Ocean Monitoring and Observing Program. So this is my office. I was delighted to join this team in 2020 and worked mostly still on the Arctic, and then was hired by UCAR to continue my work in the office with a slightly different focus. And my office's mission is to provide and support high quality global ocean observations and research to improve our scientific understanding and inform society about the ocean's role in environmental change. And we really support and observe everywhere in the ocean, mostly the global ocean and the open ocean, but also coastal areas. We have a lot of programs that you probably heard about. There were also 2 Other program managers within GOMO that gave a CPAESS seminar series a couple months ago, Cheyenne Steenberger, who talked about TPOS and the Extreme Events Program, and Kathy Tedesco, who talked about her carbon program. So make sure you go back and rewatch those if you're interested. Anyhow, I wanted to start out saying, why are ocean observations even important? That's what my office mostly does. We provide a lot of the global ocean observations and about 50% of them. So we're very entrained in that realm. And I'm sure I don't have to tell you this story, but I'm sure everyone knows that the ocean is critically important. It provides a lot of our oxygen. It absorbs a lot of the carbon that is being put into the atmosphere. It provides food security for billions of people, and it absorbs heat and has a critical importance in driving weather patterns, extreme events, and the climate itself. And what underpins that are ocean observations. Without ocean observations, we might as well do a guessing game on what is going to happen. So these are critically important. And although we often talk about the ocean and the coastal areas that the ocean and the influences on the climate it impacts, it doesn't stop there. It also affects everyone on land. These climate patterns, everything that we're seeing in the atmosphere impacts where wildfires occur, extreme events, as I already mentioned, droughts, and other phenomena. So it is critically important. As I wanted to acknowledge Craig McLean, who started this saying that I hear all the time still, as if you like your weather forecast, think an oceanographer. And GOMO partners with a lot of organizations, not just within the US realm, but beyond. And we have a lot of different programs. For example, if you go back to the TPOS or the Carbon Talk, you'll learn a lot of the collaborations we have in different spheres and in different geographic areas. But these are just some of the GOMO partners that we on the regular and everyday talk to and collaborate with to make these cruises, deployments, and all of those things work, making the data available and everything that comes with it. These are some of the key ones that I work with every day, and Cindy already mentioned a couple of those. But today, for this talk, I wanted to focus on these four: the Global Ocean Observing System, the Ocean Observing Co-Design Program, which is a UN Decade program, the UN Decade, and the World Meteorological Organization. And all of that work that I'm going to introduce is underpinned by international collaboration. And what I want you to really take away from it is how much we can accomplish if we're going beyond our borders and collaborate with other entities, other people, take into account other people's views, learn from each other, and drive this change. So first, I wanted to go into the Global Ocean Observing System, and beyond that ocean observation realm. And I wanted to quickly introduce what GOOS is, because I'm not sure if everyone is aware. So GOOS is as I already said, the Global Ocean Observing System. It sits within the IOC, UNESCO IOC in Paris. That's where the main headquarters office is. It's a permanent global system for observations, modeling, and analysis. And the three target application areas that this office specifically works on the global scale is climate, forecast and warnings, and ocean health. And the GOOS structure is we have a GOOS steering committee that is represented by about 26 different countries with experts that give us expert advice on what we should focus on, where our priorities should lie, where national priorities come into the activities that we're doing underneath the GOOS steering committee meeting and all the panels and the additional corporations that exist. So here are the main groups that sit officially under GOOS. It's the Observation Coordination Group, and I'll go in one detail in a minute so you get a better understanding of what that actually means. The IOCCP Bioeco panel that focuses more on biological and ecosystem observations, OOPC on physics and climate. There's a modeling panel underneath it, and then regional associations that try and work in that regional aspect, because all of the other groups really have that global view. And then underneath, newly formed are the UN Decade programs that focus on different aspects of evolving the ocean observing system, and then specific projects And in the red asterisks, you can see where GOMO specifically has direct leadership in. So we're not just an office that funds global ocean observations, but we're critical in providing leadership and support to all of these components on a global level. So I wanted to quickly go into the observations coordination group because that's what I work most closely with. They're working to efficiently operate, maintain, coordinate, and integrate in situ global observing systems and networks. So the networks are listed on the right there. Those are considered the global ocean observing networks. And the group has an executive group, and we operate around 8 foci, and we're trying to get those networks to a mature level to following those foci. So developing observing requirements, maturing with the observing system, and providing gaps that are being identified, making data available and data streams clear and data flows fast, and ideally in real time provision to operational services. We work on capacity development. We develop best practices that are published. We're working on metrics and environmental stewardship. And assessing this on a yearly basis, we deliver a report card that looks at different topics and assesses the networks on their readiness and where in the maturity level they are. So what does that specifically mean? I pulled out a couple of activities that we've been recently more and more working on. One of them is the data flow. We're actively working on getting the data in real time in available services. They are currently, yeah, that's a whole different topic that I can talk about another day, but there's some work going on where we're trying to make data available that makes it on the WMO GTS into a freer format that's easier downloadable and usable by everyone. We're working on new networks that focus on different pieces and different observations. We're working with them directly, managing risks when it comes to like buoy destroying and vandalization or EEZ issues, or on bringing biological observations onto those platforms. So GOOS in total is an established array, and about 86 countries contribute to it currently, with nearly 9,000 in situ observation platforms and about 170 satellites. And this is just a snapshot of all the observations that are currently ongoing. And fun fact, GOMO funds about 50% of all of these little dots that you see on the map. So that's an important fact to take away. So you probably look at the map and think, oh, great, we have so many observations. We don't have any problems or don't have any gaps, but that's not quite true. We still have a lot of observational gaps, and there is just some listed here. And one big problem that was identified in the last couple of years, at least in my realm, is that the current ocean community is very science-driven, and we need there to be kind of a shift. So we don't have disparate projects, but long-term, maintenance, sustained ocean observing that can deliver and be pulled together into products and services that stakeholders need. So what do we do now? For that, we've been working on a UN Decade program called Ocean Observing Co-Design. And this is hosted on one of the GOOS main 3 UN Decade programs. It's led and chaired by David Leglow, my director, and Sabrina Spike from France, co-chaired by Emma Haslop, who is currently the acting director of GOOS, and with support from Andrea McCurdy, who is also at UCAR. And I am the early career ocean professional on the program. And I want to quickly introduce a couple of definitions because they're going to come up over and over again in the rest of my talk, and I want to make sure that we're all on the same page. So these are the definitions that we have set for the program. The ocean observing value chain is representing everything from execution of the observations to data management to service and product delivery to end users. Stakeholders, we refer to anyone who has a vested interest in said value chain. And for co-design, we understand it as a continuous process, a collaborative and iterative effort that involves all stakeholders. And the important piece is that we practice co-design through bringing stakeholders into the decision-making early in our project development. So saying that, I kind of alluded to some of these key challenges already, something that we had pointed out, or the international communities, when I'm saying we, was that there's not enough information in some areas. There's still data sparse areas, especially when we're looking at specific phenomena. There's a need to set clear priorities for investment, which currently only sparsely exists. And we need to connect across the value chain. As I said, there was a lot of motivation from the science community to come up with projects, get funding, and move these along. But what we're trying to do is really connect the value chain, specifically the modeling observations groups, to talk to each other and create that streamlined value chain, so we can come from a planned observation into product delivery, which is a big ambition. So the program really tries to evolve the ocean observing system to be co-designed and end-user friendly and be responsive to user needs, so we can change observations to deliver products and services as they're needed. So the scope and hope, what we're trying to deliver with before, hopefully, or by 2030, is a link across the value chain, a blueprint for services where they don't exist, a design for observation and forecast systems, tracking of implementation and making sure that we're making progress, and an economic value assessment to raise visibility of the importance of ocean observation and the community to governments as well. So how do we begin? For this, we looked at the national priorities and topics that came up and things that were mentioned in different international fora, and collaborated with a variety of different people across the globe, and identified these 6 areas as key societal need areas. These include ocean carbon, tropical cyclones, marine life, marine heat waves, boundary currents, and storm surge. We have brought together a group of co-chairs for each of these exemplar areas, as we call them, to then look at where are the gap areas, do a stakeholder assessment. We had a large workshop about a year ago, I think, yeah, it was last year, where we brought together people who've been working in the co-design realm to learn from them about what does co-design mean, what are critical pieces that we need to take into account when we're working on these projects. And we did so we had that, we came out with a report with the recommendations, and since then we've been working on project outlines. So what exactly, for example, the tropical cyclones or boundary currents want to do, in what area there are sparse areas, what are the observational requirements that we're needing to follow. So we're currently in this like first 1 to 2 year realm where we're working on the engagement and the designing of a preliminary draft project for these 6 areas. The next phase will be filling the observation gaps and developing requirements for observations and refining the delivery. And while we're doing that, we're working on the stakeholder engagement and having that continuously. And then hopefully in 3 to 4 years, we then get to the implementation phase. And I know this probably sounds really confusing, so I wanted to give a quick example of what this looks like. So for boundary currents, which I'm part of with Tammy Morris from South Africa, we identified boundary currents to be a critical need to resolve and to better understand, as they're highly variable, they're highly energetic currents, and the prediction is critical for short-term seasonal weather forecasts, for climate adaptation, regional fisheries, food security, and blue economy. And it was identified that these are very critical in understanding, especially the impact on marine heat waves, tropical cyclones, and marine life, and the distribution of, for example, fisheries. So the goal was to deliver an ocean observing system that directly feeds into delivering products and services for ocean industry, and understanding those impacts on those specific phenomena more detailed. And we looked at different pilot regions, and the Agulhas current is one of the most data sparse boundary currents. So we chose that as our first pilot region. So what we did is we assembled a group from OCG, GOOS. We looked at local observers, modelers. We invited representatives from the tropical cyclones and from marine life that all came to a meeting in South Africa about 2 months ago. And we had a whole analysis of what's already there in the array in South Africa, what are critical gaps that we need from all these different tiers. So we talked about what does the scientist need, what do the observers need, the modelers, and the operational systems. What are their critical needs? And we determined a set of key questions that were raised, and then now developed a draft design for an observing system for the Agulhas current, which includes a backbone array and then smaller process studies that are focused on BGC and a biological focus. So we are currently in this stage where we have that draft design, and now we're engaging a few people to finalize our stakeholder mapping. So looking at specifically who are the stakeholders for the boundary current system, and who are they, the people, not just a term like fishing industry, but having specific representatives, and looking at where are those cross sections and groups that we might be able to approach with our plan. So we're currently in that stage of finalizing that and doing a little bit of brainstorming and prioritizing them, because there's hundreds of stakeholders you could look at, but we need to decide who are the key priorities, because we can't do this for everyone, but it will be slightly different depending on what area you look at and what type of phenomenon you look at. So after that, we're planning a stakeholder engagement and consultation process where we're bringing our current design and the key questions that we identified with already observing modeling groups in the region, and presenting that to the stakeholders and talking to them about what are your needs and what are you needing from this observing system. And with that, we then want to revise the observing system plan. And after that is complete, we would then have a total set of observing system requirements and would go in the implementation plan, where we're then trying to implement these observing systems and actually put platforms into the water, and making sure and developing metrics to make sure that what we're doing actually impacts the product and service delivery. And I mentioned before that the co-design piece is an iterative process. And what I mean by that is after the platforms are in the water and we're tracking that they're actually making an impact, we're not just stopping at that point, but we're moving along. We're revisiting that and looking at that there's actually an impact. Are there other gaps? Are there things that came up that we can resolve and where we need to change the plan? So we then go through this whole value chain again. So we skip the stakeholder mapping, or maybe revisit it, but do a stakeholder consultation and keep them appraised of our outcomes, and potentially revise our plan again, and then make changes to the observing system that's been implemented to make sure that the stakeholder needs are met. So I hope that gives everyone a better idea of what this process is meant to look like, rather than nice words. Yeah, so I talked a lot about observing requirements, and I wanted to talk a little bit and spend a little bit of time on what that actually means and where that term came up, so everyone's following me. So it's a specific process that is being done by the World Meteorological Organization. It's a specialized agency, or WMO, a specialized agency under the United Nations, and it's responsible for promoting international cooperation on atmospheric science, climatology, hydrology, and geophysics. And it has about 193 member countries and 6 territories. And the mission of the WMO is the international cooperation and coordination and states and the behavior of the Earth's atmosphere. So they're very atmospheric driven, looking at meteorological impacts, atmospheric impacts. And they have a process called the rolling review of requirements. And what this means is they have a process that collects, vets, and records user requirements. And these users are most of the time just operational centers and then match them to observational capabilities. So they look at, for example, surface, like air temperature. And then they have specific requirements that is listed for what the specific ranges are, the units, how often it should be recorded, and where the data should be housed, and have all of this information in a database. and they revise this on a regular basis and look through application areas, which I will go over in a minute. And then they create a high-level guidance document that summarizes the gaps. So after they look at these are the requirements and these are the observational capabilities, they call out the specific gaps and create a list of priorities that gets updated every 5 years and that distributed among the member states. And then the member states need to do their best to fill those gaps. Yeah, and that document heavily relies on having this rolling review of requirements, or the RRR process, be regular and updated. And they have experts that are assigned to specific variables that are being observed. And they're basically in charge of updating that on a regular basis and consulting with the community to make the best estimation. So they're looking at specific application areas that are relevant to the WMO. And what has been added in recent years is number 9, the ocean applications and the climate monitoring. But this is important because the ocean hasn't always been seeming the highest priority here. And we're getting more and more recognition in this area. And as I said before, and as I'm sure everyone on the call today knows, the ocean is critical in resolving atmospheric variability and weather patterns. So this has been really exciting because a lot of push is now happening to get the oceans more established in the WMO processes. So in terms of requirements for the ocean, what I talked about until now, it's all atmospheric and maybe the surface ocean temperature, and it's very limited when it comes to ocean observations. So when it comes to ocean-related requirements, we have some that fit the ocean from the rolling review. The GCAS develops some on essential ocean variables and climate variables, but they are more climate focused, and OOPC develops some. However, there's no common forum at this point to develop requirements on a more regular basis and a global basis or even regional basis. There's few examples for that. Some of them are TAOS or TPAESS. They have developed things like that for specific regions for a specific purpose. But it's currently unclear how observing requirements from, for example, the rolling review or GCAS are impacting prioritization of ocean observations, key metrics, how it's driving any of the decision making beyond that. So what we're currently working on is a requirements workshop to address that need. It's been coming up more and more in different meetings. And we're working on this requirements workshop where the goal and the motivation is to develop this common forum where we can bring together the community and talk about these processes and have a similar regular basis analysis of ocean observing requirements and develop the same thing. And then have a specific document that we think can then refer to when we're going and asking for funding to develop these things. And these are all linked, and I will go in that in just a second. So we want to understand and factor in user needs as well, and not just the operational centers, like and make sure that that prioritization is part of the process and evolve the observing system to be responsive to these needs. So the outcomes, what we're hoping is a consensus on terminology, what requirements means, because everyone has a slightly different view on what that actually means, and develop guidance and a framework for requirements and what that would look like, and a process that can then be boiled down into like a regional need and looked at. And at the same time, we're looking at hosting a specific workshop for the Atlantic, because that's what I work in a lot of the time, to look at Atlantic requirements. So we're developing the larger process, what it can look like, and figuring out what questions need to be asked, what process needs to be developed, and how can we take those requirements that are being developed and then apply them to a regional need, and then develop that and use it to go to governments and other agencies to make prioritization and observation, prioritizations. So here I wanted to quickly remind everyone about the requirements through the co-design process through boundary currents. So what we're hoping to develop is after this process, we would then have a set of requirements for observations. We can then go to, for example, boundary currents where we're already kind of developing that on a specific phenomena base, develop specific observational requirements for boundary currents, and then implement that. And the user piece comes into account when I was talking about the iterative process. So it's kind of where everything fits together and pulls it together. And the critical piece here, what I wanted to mention is there's an opportunity coming up that I just wanted to quickly announce in case people haven't heard about this yet. The WMO hosts a assessment of various observation system workshops. They do this every 4 years, and they specifically look at do changes in the observing system for atmosphere make impacts on weather prediction? And they have specific questions that they're following to address this need and look at the assessments. And we're trying to get the ocean more represented in this area as well. And this year, next year, when the meeting actually happens, there's a lot of ocean-related questions that are being considered for this conversation. So that might be of interest to some of you. And this is a pretty critical piece because, as I said before, in WMO, the ocean hasn't been the most represented piece and not been taken into account to the extent that it should have been. So we're working closely with, specifically in the GOOS world, working with the WMO to get oceans more represented and getting that process going. And now I'm ending a little bit early, but something that I wanted you to take away from this as well is that none of this work would be even doable without international collaboration. I speak a lot to international people in different organizations, and we collaborate and learn from each other. And a lot of these example scenarios that I presented on today, like the co-design program or the things that we're trying to do with the WMO, wouldn't be possible if we wouldn't have friends abroad that we could come up with these ideas, brainstorm these ideas, and then implement them. And from just linking back to the beginning of my presentation, the weather patterns and impacts that we're seeing on society don't just stop at the border of a country, they affect everyone. So it's critical that we're talking to each other and collaborate with each other, and we can achieve quite a bit if we're collaborating effectively. I know there's some challenges, but if anyone has any questions, please let me know. We had a very successful meeting in South Africa, and we have a lot of people who had a lot of interest in this and are able to now move forward and make a lot of progress in the boundary currents piece. So I'm really excited about that, and I'll stop there.
Thanks very much, Anne. Absolutely fascinating work that you are doing. I want to encourage everybody to add questions into the Slido. Remember, directly underneath this presentation, you would find those. And one thing that I was thinking about is that there's a lot of focus on the observational framework. Do you have any links to modeling so that you know what is coming in the future, so that you can also adjust your plans for what is happening in future climate?
Yeah, so specifically when looking at the UN decade, how am I going to explain this? There's different components to the UN decade, and one of them is these decade collaborative centers, and one of them focuses specifically on predictions, not only ocean prediction, but also looking at weather prediction. And we're working closely with them to take that into account. And they're made up of an international group that represents modeling communities from all over. So we're able to use that resource and go to them, and we have taken that opportunity to talk to them and tell them this is kind of the areas that we're looking at advancing some pieces, and they're then able to help us identify local groups that we then can specifically talk about. And one example is the boundary currents group. We looked at I didn't know anyone in South Africa who works on models and looks at the impacts of boundary currents. So they were really helpful. Yeah, and if you need any information on the DCCs, what they're called, they're online, and I'm happy to share that. There's different ones. There's one on ocean observations as well. So those are really great groups to plug into.
Since we're still waiting for other questions, and as I said, please people, type away. I have one more question for you, Anne, and that is, WMO is a really key player in doing this. Is there any talk on the WMO side to turn this work, which is really important and need to be highlighted, into a lighthouse? Do you know that? So they have these lighthouse activities that they focus, or that they have as a high level activities on the WMO, and not the WMO, on the GWEX side. And I was wondering if there's any connection there to give it more profile.
Not that I'm aware of yet. We talked to a couple people specifically in WCRP who work closely with, I think, the lighthouse activities. But there's different pieces, and I'm hoping that answers your question, but there's different groups collaborating right now, and different, let me back up. There's different structures within WMO, and we're mostly collaborating with the Infrastructure Commission, which works a lot on the observational requirements. And that's where we're plugged into. So we've been talking a lot to the group that organizes and operates the rolling review of requirements, and figuring out pieces where the ocean needs to be part of the discussion, because they haven't always been. And we have a clear plug-in for that way. So we're able to influence the RRR process in terms of the ocean observations. Something else that we're working on is there's a group that called the JCB, the Joint Collaborative Board, that works between the WMO and the IOC. So the IOC being more our scientist world, and WMO more the meteorological world. And we have someone from the ocean representing us on that board, and are able to get more information and have more influence on the priorities that the WMO sets. There's also, I'm gonna rant here a little bit. The GHG, the gas, I'm blanking on this one now. They're looking at greenhouse gas groups, and we're plugging into that. We have specific people working specifically in the carbon world that are plugged into that to make sure that the ocean is represented in that piece, because they're really looking into forecasting and predicting that piece better. And something else is that we're working on, where we have some US representation, and I'm sitting on that board as well, is called the Advisory Groups for Ocean. They just initiated that, and we have our second meeting next week. But we're looking the group specifically looks at how to better connect the ocean to all the efforts that the WMO does, and ensuring that the ocean community is represented, and that we're getting into that that sphere. I hope that addressed your question in some way.
That was great, thank you, because I think a lot of the work that you guys are doing is not always as visible, but it is good to see that there's these connections being made. I see we have a very interesting question that came in. You mentioned, if you like the weather, thank an oceanographer. And the question is, and what if you don't like the weather?
That's a good question. Then you still thank an oceanographer and make your priorities clear. And that's what, yeah, that's why I think the collaboration with WMO is really important, because they're working a lot on the operational forecasting, short-term weather forecasting. So getting the ocean there will only resolve our weather forecasting better, and activities like the exemplar areas on, for example, tropical cyclones is really important, because we can more closely influence and make sure that the product delivery, what you're talking about, is getting proper weather forecasting, will be better represented. So it's not a short-term solution, unfortunately, but I think we're moving in the right direction of having that, having more of that representation, which will, I don't like the weather always either, but unfortunately, it's more complicated than you think.
Very well put. We have another question from Mike. For the value chain, how reliant is the demonstrated value of the ocean observations on the quality of model forecast? And are there value chains of products other than forecast? So real-time monitoring, state estimates, trend assessments, time series analysis, etc.
Yes, good question. Yes, they are. Forecasting is just one category, which is why we're separating for example, for the co-design piece. I'm just going to use it as an example. For each of the societal benefit areas, we look at who those stakeholders are, and forecasting and might be one portion, but we're also looking at different levels, which is why we're doing the stakeholder assessment for each of them separately, because it's depending on what level you're looking at and what timescale you're looking at, your stakeholders are going to be different and your interest areas are going to be different. So yes, and wait, let me read the other question again. How reliant? That's a very good question. There have been some studies done that look at how ocean observations influence the quality of models. And there's one specific group that is working on that and doing a couple-month experiment right now called SYNOPS. And they're looking specifically at how observations influence models and how much and how well do they improve them. So they're doing a whole scenario run, or what you call OSE or OSSE studies, looking at taking out specific observations and looking at how the model is being influenced, and what platform combination results the most accurate model and forecast prediction. So there's activities going on there. They're just usually quite expensive. So we're looking into the options there, but that will be part of the implementation phase and the development of the metrics to make sure that when we're putting the observations in the ocean on the draft design that we developed, that we're actually having an impact, a positive impact on the models.
Very good question indeed. I've just been thinking one other one is we've seen such an incredible change in the ocean as well as the atmosphere over the last year because of climate change and things is really, this year specifically, I think the observations are higher than what it has been historically. And because the ocean is so difficult to monitor, being a vast area, how does that impact what you do to actually get new data and up-to-date data in a timely fashion?
Yeah, so something that I'm working on, well, semi-working on. I work on a group that works on that. So for example, we work with the networks, the global ocean observing networks that put actively platforms in the ocean to observe the ocean. That's within the observations coordination group. And we just developed, Kevin O'Brien from NOAA and Washington University, he developed a data strategy that looks at how we can make the data more accessible. And what he's working on is, so for anyone who doesn't know, the WMO has the global telecommunication system where the real-time information from satellites gets sent to, and it's then available, and then you have to then, as an operational center, subscribe to that to then download and access the data in real time. And what a project he's working on with WMO and NOAA is an open GTS, which allows him to utilize ERDAP services to download the GTS data onto the ERDAP service and then make it available for download. So you don't have to then be subscribed anymore, which can make it extremely difficult to get data, but you can use the ERDAP service. And another important piece of that is that the GTS from the WMO has a very specific data format that is sometimes very hard to decipher, and not everyone has the capabilities to do that. And what the ERDAP service allows you to do is to download the data in the format that you prefer. So it gives you different data formats. So that's what he's currently working on. It's a specific project under the WMO as well. This is where it gets really complicated with all the terms and the acronyms. But there's a whole process under the GTS area called WIGOS, and that's dealing with that real-time data. And they're looking at evolving the system So this is more easily accessible through the WMO already. But he's actively working on that, and he sits on the OCG team, and we just wrote a data strategy to look into that and did a whole data mapping of the different countries that put, for example, Argo floats in the ocean, and where does that Argo data go, and where is it housed, and which portals can you access. And he looked at where the gaps are and kind of the stock pipes where the data is hard to access. And we're working on that currently with the networks itself to smoothen out that process. I hope that answered your question.
Thank you very much, Anne. As I said earlier on, fascinating talk, fascinating work that you're doing. Keep up the good work. I know there's a lot going on in your world right now. So thank you very, very much for this. I also want to thank everybody for coming to our Discover series. It's always good to have these and hear what our science staff are working on. If you would like to present in our CPAESS Discover series, there is on cpaess.ucar.edu, you would find a link where you can submit your title, and we would find a slot for you for the next up and coming slot. They are always the third Wednesday in the month. And if you can't find those, please send me a link or send Alex a link, and we would help you with finding this and finding a date for yourself. This specific talk is going to be uploaded to YouTube once everything is done, so you can go back to those and reference that if need be. Our next seminar will be on October 18th, and that would be by Julie Mullenberg, which is our Chief Learning Officer, and she works with CPAESS and USGS, and she will be talking on building a comprehensive workforce development and training program. And with that, if we don't have everything, if we don't have anything else, I want to thank everybody again. And specifically, Anne, I really want to thank you for sharing this research with us and your experience in the field.